What's up, AP Stats? Lesson 1.7. We're continuing quantitative data, and today specifically we want to describe characteristics of quantitative data distributions. In a previous lesson, we mentioned how we can actually display quantitative data. We talked about dot plots, we mentioned stem and leaf plots, and we discussed histograms. So, usually with stats, we start off with like raw data. So that's just like a list of numbers. And with this list of numbers, we want to understand this data. We want to try to understand if we see any patterns, recognize patterns, and use that data to make decisions. So just having raw data sometimes doesn't help paint a picture. So what we do with that data is we make visuals, right? And those are the dot plots, the stem and leaf plots, or the histogram that I mentioned. And based on that, it's a lot easier to see any sort of patterns. So once you have your visual display of your quantitative data, we want to describe this. And that's where we can start to see any patterns or anything unusual that shows up there. Right, and in statistics, there's a very specific way in how we describe the data distributions. So I'm going to draw a couple, well, actually three. I'll draw three random data distributions. So the first one, I'll do a dot plot. I'm not even going to put any numbers on the x-axis. When I say data distribution, I'm talking about like, what is the shape of this? How spread out is this data? Where's the center of this data? So that's just some random dot plot. You don't have to copy this dot plot down. You don't have to copy this histogram down either. So here's just some random histogram. So this is what I'm talking about when I say we're trying to look to describe these things. We want to describe dot plots, or histograms, or even stem and leaf plots. All right, and I like to draw right over the histogram or dot plots or stem and leaf plots, as it sometimes helps understand what type of distribution we have. All right, so I have not given you any really main information here, but pretty much the rest of this lesson is going to be me giving you vocabulary on how to describe these distributions. All right, so today's a lot of vocab stuff, and you'll hear me use this vocab like the rest of the year. So definitely copy the rest of this stuff down. So when describing data distributions, you need to talk about four things. First is the shape. And I will mention what all these things are and how we can describe the shape. The second thing, center. We want to describe where the center of whatever data distribution I give you is. So if that's a histogram, or if that's a dot plot, or a stem and leaf plot. Then we want to talk about the spread. And what I mean by that is how spread out is the data from the center. Is it all really clustered around the center? Is it all pretty far out from the center? That's what we mean by spread. So shape, center, spread. And then the last thing would be any unusual features. And with the unusual features, we're just talking about two things. Do we have any gaps and or outliers? Actually, I'm going to say possible outliers. Sometimes it's not always easy to tell if something's an outlier, but maybe it looks like it could possibly be one. So describing these data distributions, we need to describe the shape, we need to describe the center, and we need to describe spread and unusual features. All right, so I'm going to go ahead and erase this, and hopefully you have this written down. And then talk a little bit more about shape. So with shape, you have this term that's called unimodal. This is probably our favorite type of data distribution in stats. And what unimodal looks like, I'll give you a random histogram here, is where the data distribution kind of has like one peak, like one high point, and that's right there. So that's a histogram. Could also be a dot plot. And we can see here that this one also kind of has one peak. So we would describe these distributions when we're talking about the shape as unimodal. Uni being the prefix for one. Well, there's also bimodal, and I think you guys can probably imagine what that's going to look like. The data distribution that has two peaks, or two like main bumps. These are definitely more rare in statistics, but they can happen. So we see two peaks there, two bumps. And then the last one for describing the shape would be uniform distributions. And this is where there really is like no peak. It's all kind of just like the same thing. The same frequencies spread out. Oops. So this last one here is uniform. All right, so when you're describing the shape, you want to mention, is it unimodal, is it bimodal, or is it uniform? And also you want to talk about symmetry. So I'll do symmetry right below this. And symmetry, we've definitely seen that word before in math. So a symmetric distribution could look something like this. And it doesn't have to be exactly symmetric. We usually say the word roughly, like roughly symmetric. I can split this data in half right there, and it looks like there's about the same amount of data on the left side as there is on the right side. All right, so we talk about symmetry. What if the data is not symmetric? What does that look like? Well, I'll draw one. Okay, so something like this. Where it's not as symmetric as the first one, and we see that these data points over here are a lot higher than these data points. So it's being pulled to the right, this distribution. So we say that this is skewed, S-K-E-W-E-D, skewed right. And I'll draw a dot plot for the last one. So the dot plot here, we can see that this one is more skewed left. Wherever you see these unusual datas, that's which direction it's skewed. So like these over here, they look like they could be possible outliers, and this one even. That's the direction that it's skewed. So when we talk about shape, mention how many modes, or if it's uniform, and then mention symmetry and or if it's skewed. So we've got shape down. The rest of this is a lot quicker. So shape, center, spread, and unusual features. So the center that you have to mention is either going to be the median which again, the median is the middle number of your data distribution, where there's 50% above it and 50% below that number. So you can use the median to describe the center. You can also use the mean, and there is a correct way to pick which one you want to use. I will not get into that during this lesson, but for center, measure of center, just recognize you can talk about the mean or the median. And the mean, you should know that that's just your average. So spread. So we did shape, the center, look at your median, mean, and for spread, you can talk about a couple different things. So if you talk about the median, you're going to want to talk about either the range or the interquartile range. Group the median always with the range or the interquartile range. So if you decide to talk about the median, you need to mention the range or the interquartile range or both. Where the mean, we'll want to talk about standard deviation. All right, so the center describes where is the center of your data distribution. The spread, we're talking about how spread out is all the data. And the range, remember what the range describes. It's the max minus min, and the IQR is Q3 minus Q1. This all helps us to define how close or how clustered or how spread out our data is. So like, let me see back up here. These are not great examples. We'll definitely define standard deviation a lot better in coming lessons. For now, just remember that for data distributions, shape, center, and spread. And the last thing, which many students forget, any unusual features. And there's only two unusual features. I said gaps and or possible or potential outliers. When I say gaps, this is what I'm referring to as a gap. So like in this dot plot, there's a gap right here. Why is there a gap? That's something to mention. Possible outliers, I think you guys remember I mentioned outliers are something that's really high compared to the data or really low compared to the data. So like for this guy, maybe the 64 is a possible outlier. There's a gap here, so that's an unusual feature. All right, you guys are going to do a few questions right now regarding these three pictures down here. But in terms of the lesson, that's it, guys. Describing quantitative data distributions, shape, center, spread, and the shape, remember, unimodal, bimodal, or uniform. And then also talk about, is it symmetric, is it skewed right or skewed left? And then for centers, we can talk about this, and spread this, and unusual features. All right, so here's your first set of questions, and that is in regards to this guy. Second set of questions in regards to this guy. Third set of questions in regards to this guy.